Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a machine learning model which can predict the heart stroke for a patient. Okay, so let's get started. So the first thing we have to do is we have to import the required packages, pandas, numpy, matplotlib, and seaborn. Then after that we have to load the data by using a pd.read_csv, and we have to provide the data sets. Now this is our data set, which is having almost 12 columns and more than 500 records. So you can see what is the size 511012. So here's the patient ID, gender, age, hypertension, here disease, heart disease, ever married, work type, residence, average glucose level, BMI, smoking status, and stroke. Stroke means it is the target variable that we have to predict. Means stroke means that person is suffering with the heart stroke, and zero means not. Okay. We can see the data. These are the columns, 12 columns actually. Out of that, ID is not important from the this model building perspective. So we are dropping that using drop ID axis is equal to 1. Okay. Then we can check what is the data type of this. So you can see gender means object, means it is a categorical one, and age is a float or integer, depends. Okay, so these are the data type. Then complete information about the data is .info, which gives the non-null values, data type, and the column name. So here you can see there are null values present in the BMI. So we can check that. Before that, we have to check any duplicate records are there. So I'm using a dot duplicated here, and I'm running. I can't see anything duplicated, so it's fine. So we have to check the null values. Is null dot sum. So I'll give the 210 values are null in the BMI. So I will fill that, impute that. I am not going to remove this because that are very important. So I'll fill that values with the mean value of that particular column. So what is the mean value? So mean value is this. So I'm inputting this. So I by using a dot fill na and health data BMI dot mean. Okay. So after that, this whatever the null values are now filled with the mean value. Now you can see there are no null values are here present here. Okay, next one is the we can explore the data by a data visualization. So first thing we have to just list out these categorical values, categorical columns. These are the categorical columns. Um, and we can display these categorical columns by using a bar plot simply. Okay, so I'm running a for loop and plotting this plot. You can see gender, uh, then smoking status, resident types, their numbers, work type, their number, and their categories. So here itself you will get the all the idea of the each categories. Okay, fine. Then we can check numerical columns. The numerical columns are age and these things are there. But out of that, heart hypertension and heart disease are 010. Stroke is also 0101. So instead of putting that, what we can do, so we'll do this thing. So we can plot the histogram for this and box plot of these three columns. Okay, so I'm using again a for loop and plotting this histogram. So you'll get the distribution of these continuous variables here. Okay, age, glucose level, and BMI. Then we can plot the box plot by using the same, only you have to change the word box here. So from box plot, we can easily see that there are outliers present in the data. You can see the outliers are the data points which are above or below these whiskers. Okay, fine. So we can check the relationship between those columns like age and BMI by using a scatter plot. So this is the relationship but we are not getting any clear-cut idea about whether they are actually correlated or not. The same thing for BMI, glucose level, age, and the average glucose level. Okay. For that, I'm using a COR, that is a correlation function here for the numerical columns only. So you can see for the numerical columns, I'm using this, and I can't see any significant correlation among these data variables. You can check it by using a heat map, sns.heatmap, then correlation matrix. Here, you can't see any the correlation more than 50%. Okay, that's fine. So yes, the data is here and our target column is stroke. So we can check whether the data is balanced or not. And for that, I can check this and value count. So you can see here the stroke means 0 is the patient is healthy and no means patient is suffering with the stroke earlier. Okay. So this data is quite imbalanced. You can see here on the bar plot, the huge number of data points are in 0 class and less number in 1 class. So we have to balance this. So how I'm balancing this? I'm considering only the 300 data points from this 4861 category, means it's a 0 category, right? So for that, I'm creating a stroke data frame separately by using this condition, stroke is equal to 1, and no stroke, I'm using the condition this. And you can see here there are 4861 records. But I'm choosing only a 300 records from this by using a dot sample. And you can see there are 300 records I have selected. Now I have to combine this data frame and this data frame. And for that, I'm using a concat function, pd.concat list of data frames, and axis is equal to 0 means it will stack. So it will put one another this row wise. It will append the row wise data. So you can see here, this is my new data frame. And what is the shape? Shape is around 549. Okay, 300 and 249. Okay, so it's 549. Okay, that's fine. So you can check now what is the 0 and 1. Now data is quite balanced one. Okay. The next important part is we have to do the feature engineering. What exactly feature engineering means? We have to do some label encoding, feature scaling. Okay, these type of those things we have to do. And for that, this first thing we have to convert all categorical columns into a numerical columns. Okay, into a labels. Okay, and for that, categorical columns are gender, ever married. These things are right. So for that, I am importing a label encoder and creating the object of label encoder here. And here I'll show you. So for the gender, I'm putting this label encoder and using a fit underscore transform so that I can apply this for this particular column. Okay. And this line I am showing what are the how these are encoded. The female means 0 and male means 1. Okay. Like this, I am applying it to each and every column here. Okay, you can see there is a category and they are coding. The same thing here you can see. Yes. Yes. Now data is look like this. It's fine. But now you can see the age, average glucose level and BMI are having some different scales. So we have to bring them on the same scale. So for that, what I'm doing, so we can use the standardization or normalization basically. And here we are having these columns. Basically, we are applying it for the age, average glucose level and BMI. Okay, and for that I'm importing a standard scaler which will standardize the data and creating the object here, and I am fitting that object to the particular column here using a fit underscore transform. Got it? So here you can see how data is transformed. Now you can see these three columns are on the same range same scale, and all other columns are in 0 1 to 0 1 2, means these are the categorical one. Okay, cool. Then next thing is what we have to do. We have to separate the data into dependent and independent. So this is these x means the dependent independent variables, and this stroke is dependent one. So y is target variable or dependent, and x is independent. Okay, fine. Next one, we have to split the data. So this is splitted the data by using a trend test split, by using a model selection, and created 4 variables basically. These 4 variables are xtrain, xtest, ytrain, ytest. Using trend test split, x, y, test size is zero point 0.2, means 20% test data and 80% training data. Random state 42, you have to seed any number here. Okay, no problem. So that we can keep this training and testing data set static. This is our training and testing data set. 20% testing and 80% training. Then let's get started with the model building. So first I will build one simple model, and then we can build multiple models. Okay, so here I'm initially considering a logistic regression, and then create an object of logistic regression here, and then I am fitting this model. Okay, after fitting we have to predict, it will predict the y values for x test, so it is called as the y predictions. Now next one, how to check the performance of the models. For that we are having the evaluation matrix, accuracy score, precision, recall, F1 score, confusion matrix, and then classification report. So accuracy score, for that I have to give the y true and y prediction. True means test values which are already there. 77%, precision is 80%, recall is 75%. Yes, confusion matrix again you can check. It's a 2 by 2 matrix here, which can check the true positive and true negative, false positive, false negative. These values you can directly see on the heat map. Yes, cool. So classification report will give you clear-cut idea about every parameter, evaluation matrix. Precision, recall, F1 score, and this is the accuracy. Okay, good. This is all about logistic regression. When logistic regression is working fine with giving the 77% accuracy. So I'm building a multiple models here: logistic, decision tree, random forest, KNN, K nearest neighbor, support vector SVM, and naive So for that I'm importing these models from the sklearn, you can see, and then I'm creating the object of these models here. Great. Now what I'm doing here, so I will do these things, creating a list of models, then I'm running a for loop. I'm fitting the model to x test, y test, and we'll get the prediction, y prediction, by using a y predict dot model dot predict. Then I'm putting this accuracy of that particular model and appending it into this list, and the model name into this list. Okay, cool. So I will create this data frame of model and accuracy. Here you can see these are giving the good accuracies, but decision tree and random forest are giving 100% accuracy. This may be the overfitting problem, so that we can cross validate it. How to do that cross validations? But we have to import cross val score by using from model selection. Again I am using this list of models, then feature means x, label means y. We have to give the complete data here. Again the same thing we are doing, accuracy score and model name. Here the only thing is cross val score, we have to provide the model. Model means this, one by one we will select model, features, labels, this y, scoring is accuracy, and cross validation is 5 times, means it will give you 5 times accuracy for 5 folds. And here we are taking the mean of these accuracies and we are appending here. We'll check which model is giving a correct accuracy. So yes, cool. So we are putting these accuracies here in this data frame. So cross val, I'll say cross val here, and you can see the accuracies. Random forest is giving a good accuracy. Yes. Yes, SVM is also good. This logistic regression also good. Random forest is highest one. So we can select the best model as a random forest, and we can tune the hyperparameters by using a grid search CV or randomized search CV algorithms. So I'm selecting a random forest and grid search CV here. I'm selecting a new parameters 50 and 100, square root and log 2, max feature, and I'm creating the object of grid search CV. Estimator is random forest model, param grid is parameters. Now I have to feed this grid search to the extend Y-train. So it will take a certain time because it will check all possible combination of these things. 50 square root, 50 log 2, 100 this. Okay. And we'll calculate. Okay. Yes. Now this is ready. What are the best parameters are n estimators are 50 and log 2. I have to select this log 2 here and create a new model by using these parameters, hyperparameters. So here I'm saying this is new model. I'm using a cross val again for that new model, and I'm checking a list of this. Now you can see these accuracies. Now accuracies are improved. Earlier it was here 78, but this is a one set of this thing uh, data. But here I am using a cross val score, so we can check the mean. So mean is 78.59. It's great. So we are getting a good accuracy from this particular model. So we are selecting a best model as the random forest with these parameters. Okay. Now we have to customize the predictions. So for that I have to train the model for X-train and Y-train. Yes, cool. So we have selected this. Now what I have to do? So I have to give this um, the parameters actually. So which parameters we are considering, that parameters we have to give. So for that what I have to do, so I have to see first data here, health, uh, health data new, and I'll do one thing here, first 5 records. Okay. So here you have to enter the values of gender, age scaled, okay, something like this, and then we have to predict whether that person will support the heart stroke in the future or not. And for that, I'm running this cell. Okay. Yes. So initially it is asking for gender. So gender, I'll say one is for male. Second, uh, enter the age. So I'm entering the age for that particular person is 56. Hypertension is 1. Disease is 1. Work type is I'll consider 2, means you can check. Ever married is yes. Resident is urban type. Then average glucose level I'll consider is 45. Then BMI I'm considering is 50. How much it is? 34. Smoking status I'm putting 2. Okay, these are the values. Now we have to calculate the probability of that particular person. Okay, cool. Now here I'm getting what will be the uh, what will be the probability of this patient is having the stroke in future. Okay, so probability of stroke in future is 60%, means yes, obviously that person will suffer from the stroke in the future. So that person has to take the precaution to reduce the to increase the enhance the diet level or some exercise or take the some diagnostic or test, consult the doctors. So this is the model where we can predict the heart stroke. This is the complete end-to-end projects. So thanks for watching. Thanks.